realize you might not be done with these four yet, but take a look at them. This is similar to what I mentioned last week about picking out the relevant information and only using. Right now, number one, FIB. Angle FIB. Ooh, I forgot to draw a line in there. Find the angle FIB. That angle right there. Find that angle. I'm going to look at this figure right here. Green. I know that's a right angle because that's a radius going to a tangent. And I know that's a right angle. That's a radius going to a tangent. And if this is 60 degrees, that whole figure, a four-sided figure, has to add up to how many degrees? 160. So I subtract two right angles and a 60-degree angle. What's left? 120 degrees. That is 120 degrees. IFH. That would be this angle right here, formed by that line. Well, this is a right angle here, which means that's a right angle in there. So if that's a right triangle, those three angles have to add up to 180, right? If this whole big angle is 120, this part has to be 60. Remember, this hits that chord at a perpendicular, so it's also an angle bisect. Cuts that angle in half. This is 60. This angle has to be 180 minus 90 minus 60 is 3 degrees. Another way to think about it is in a right triangle, since we know one angle is a right angle, the other two angles have to be complements. The other two have to add up to 90 degrees. That's 30 degrees there. We have angle ABH. ABH would be this one right here. Okay. Well, we pretty much already know what this angle is. This angle is how big? 30. This angle has to be that is a right angle, but we have to combine they have to be complementary. They have to add to 90 degrees. Arc KF. Arc KF is right here. It'll be the same as this angle in here. How big does that angle have to be? Well, this isn't. You have the right idea.
Yeah.
That's a line, so this one's 120, that one has to be
60.
Add up to 180. That angle 60, the arc is also 60. Now let's throw some other information into this mess, just for fun. I'm going to tell you that IB is 6 inches. What's that tell us? Let's say IB is 6 inches. IB is there to there, so that is a J 2 inches. PJ is 4 inches. I ask you to find When we look at this, IB, of course, being 6 inches, that tells us the radius is 6 and the diameter is 12. Because it's really the diameter that we want. Because we know DJ here is 2 and CJ here is 4. We're looking for EJ. We need to know GJ. To find that, we have to know the diameter. This over here is 2, and the diameter is 12. GJ has to be 10. Now, how do we find EJ? Multiply the pieces of the chords. 2 times, what's the other piece of that chord? 10 has to equal 4 times x. What's x have to be there? 5 inches for EJ. Let's put a few more up here with that. Arc DK, arc BGF, arc KCB, arc FG. Actually, let's do this. Let's say if FG then that means angle IFH has to be 1. Let's do those 5. We'll give you a minute, then we'll come back and take a look at it. Take a peek and see what you got so far here. So DK, that's this arc right here. Well, we have 60, 60, and this has to be, add up to a line, 60, perfect. That is a 60 degree. EGF is just this arc around here. It has a central angle of how much? 120, so it's 120 arc. KCB, that just means we're going this way. KCB, how big does that have to be? 180. It's cut by a diameter. And we've already found IFH once before. How big is that angle? 30 degrees. Next, arc EB, 150 degrees, and arc CB, 100 degrees. Find guy. Roll up here, see everything. So angle CGI is this angle right here. A lot to this one. Really looking at is these two intersecting chords. That means to find those two intersecting chords, we would need to know the size of this arc, size of this arc. Angle formed is just the average of those two arcs. Well, the first thing we were given was EGB. That's from here to here. That's 150. Well, we already know that from F to B is 120. So by subtraction, that makes this piece 30 degrees. The reason that's important is from F to K was degrees. So if this piece is 30, that means this piece is 30. We already knew this piece was 60, so that means from here to here is and down here we know that this piece is 60, and we're just given that this piece is 100. So that means from here to here is 60. Angle CGI I should say, is 160 plus 90 by 2. With a 2 or 125 degrees. That one's a bit tricky. That one might not have been one of my kind, just ones. This next one should be pretty easy though. If I tell you that FH 4.5 inches, how big is FB? relationship here. This FH right here. FB is all the way down. The obvious answer is true. So, because this is a right angle here, that radius does cut that chord in half. So. Oh, let's review parallel line stuff a little bit. Nine angles to find. Find the 9 angles. Yes, sir. We'll give you a few minutes to find those and then we'll go over them. one of those where I numbered the angles the way I did purposely because people tend to want to do them in numerical order. If you try to do it that way, it's really difficult to do. One of those problems where it's best to look at it and figure out what you can find easily first and then look for the other stuff. Let's start with the 60-degree angle here. What other angles have to be 60 degrees? 4 and next, let's look at the 40 degrees. What other angles have to be 40 degrees? No other marked angles, but I'm going to mark this one as 40 degrees just because that's going to be important. We have the 110, and it looks like the 110 doesn't mean much to us until we look up here. This angle has to be 110, doesn't it? Which tells us that angle 8 has to be now, the 110 also tells us angle 9 here, because these three angles have to add up to how much? 180. So 110 and 140 is 150. Angle 9 has to be 30 degrees. Angle 8 is 50 degrees. This angle here has to be angle 7. 100 degrees. Whereas this angle here would be 80 degrees. So I could have found angle 7 by using that triangle. Could have added up this triangle and then did the supplementary angle. Now, these two add up to 110. So angle 1 has to be how much? Angle 6 over here. Has to be supplementary to the 40. And angle 5 down here has to be 120. Supplementary to the 60. So if you go like that, it's not that bad. So it's just a matter of picking out what information you can find and finding. Don't even look at the numbered angles. Just find what you can find until you look at it and realize, oh, I've got everything I need. Then fill in your answers. So today I want to talk briefly about one of these things called a compass. You can see it, the angle adjusts, opens and whatever, and it locks in place. So if you know what radius you want to make a circle, let's say I want to make it the radius of this pen, I set that in there, I measure out, make sure it's set to that width, and then I tighten it down here to lock it in place. Then to make that circle, of course I'd have to take the pack. This is old enough that it actually was chalk originally. But you can do with duct tape and a marker, right? I have to take the cap off my marker. I would set this point at the center, where at the center of my circle, and just spin it around, and it makes a perfect circle. So when I say strike an arc, that's what I mean, is you're going to set this point at one end point, and you're just going to go like this and make an arc. And in geometry, that arc is a very powerful tool. I mean, the obvious thing we can do, copy the length of a segment. Now, use a compass for doing any sort of constructions like this. It implies we have some sort of straight edge, but not a ruler. A ruler has the markings for measurement. We're applying it. We have something we can trace a straight edge on, a straight line from, but it's not measurable. So it could be the edge of a piece of paper or just a straight stick or whatever you have, the edge of your notebook or whatever. So if I have a segment here, I'm going to call AB, and I want to copy that length. I'm going to take a straight edge, take a segment that I know is longer than AB, So I'm exaggerating a little bit here. Then I take my compass, set the tip on one end, pencil on the other end, and I just come down here, I put my tip on one end, I strike my arc, and there it is. I erase the rest of that line. Copied that segment. That was pretty intuitive, right? You're basically just measuring it with the length of the compass. Let's copy an angle. This is a little less intuitive, but actually kind of a neat little thing. So I'm going to start out with a similar thing. So I've got my angle that I want to copy. I'm going to start out with doing just one side of the angle, or a line segment. I'm going to specify where I want my vertex. Now I'm going to take my compass. I'll put my point right here again, and I'm going to set my pencil at whatever radius is still on this angle, and I'm going to strike an arc like this. Now the power of the compass is once you lock it in place, it stays there. You can make as many arcs of that exact size as you want to. So I'm going to come over here and I'm going to strike an arc the same radius, making sure I go up plenty far here past where the other side of that angle is. Now I take my compass back here and I'll put the tip here, pencil right there, measure that width across there. Come over here, put the tip here, and I'll strike a little arc across it with my pencil. And now my straight edge can draw a line through there. Those should be the exact same angle. I want to copy a triangle. Once again, I start off just a straight line that I know is longer than the side that I'm trying to represent as it. ABC. Copy this as ABC. First thing I want to do is I want to copy the length of one of the sides. So I'm going to copy this length here. So again, I put the tip of my protractor there, my pencil over here, and I lock it in place to get that length. And I do go over here, put my tip on A, strike an arc to get my length. Draw that in. This is technically point B. Next, I have to copy one of the angles. So that's just what we did up above. I'm going to copy this angle here, angle A. I'm going to strike an arc there. Over here, I strike the same arc, top of A. Now I will say this, the bigger the radius of that arc is, the more accurate it is, the more precise it is. If I come out here, right, when I measure across here, if I come here and I'm off by just a touch, it makes my angle off by way less than if I'm way in here and this is off by a touch. Does that make sense? Further away from the vertex you get, the more leeway you have. So anyway, I put my tip here and my pencil there to get that distance. Come here, put my tip, mark my arc. Draw that line segment in. I've copied this angle here. Now there's two ways to proceed. I could copy this angle down here at the other end, but the easier way to do it is to just say, I'm going to copy this length. I put my tip here, put my pencil on that end, tip here, mark out my pencil. Oops. We just draw that side in. There's my triangle. So a compass and a straight edge can be used to copy a lot of things. If I want to cut an angle in half, that one's kind of cool. Bisect an angle. There's my angle I want to bisect. But I do just like I'm going to copy an angle. I put my tip here, take my pencil, make an arc across there. And then I can change it, the radius if I want to here. Usually it helps to make it a little bit bigger. I'll put my tip here and my pencil out here, strike an arc. Now I got to leave it exactly the same. My tip here and my pencil out here to strike an arc. Now if I draw in using my straight edge, that segment through where those two arcs intersect, that should cut that angle in half, should bisect that angle. Want to cut a segment into equal pieces. Let's say I have this segment right here. I want to cut it into 4 equal pieces. 4 would be easy. I could cut it in half and I could cut each of those in half. Let's do 5. Cut it into 5 equal pieces. I'm going to just draw another line over here. Then I'm going to set my compass at a length. Because I know it's short enough that I can get 5 pieces on that line. So I'm going to put my tip here. Mark an arc over there. Now I'm going to put my tip on that arc, mark another arc, put my tip on that arc, mark another arc, mark another arc, mark another arc. Each of those pieces should be equal, right? But they're not the ones that, it's not my original segment, it's the new one. So I'm going to connect this last spot here, the other end here. And I connected those lines straight. Points of the straight line. Now I'm going to come back and I'm going to copy this angle right here. So I'm going to make an arc there. I'm going to come here, make an arc. Come here, make the same arc. Put the tip there, make the arc. Put the tip there, make the arc. Copying that angle at each of those little arcs on the line. And I put my tip here. Find that length with the pencil. Come here, put my tip. Mark the arc. Tip, mark the arc. Tip, mark the arc. And well, that halfway is close to right. Drawing those angles, I copy those angles. Those pieces should all be. The reason I switched to 5 instead of 4, if I can cut an angle in half, it's called cut a line in half. It's called bisect a line. Just like bisecting an angle cuts it in half, bisecting a line cuts it. I have a segment, I want to cut it in half. I take my compass and I set the radius so that it's more than half of the segment. I put my tip here, my pencil here, and I mark this arc. Making sure I keep it the same, I put my tip on the other end. I mark the same arc. Connect this through those points. This should do 2 things. Cut the segment in half. Those 2 pieces should be equal, and that should be a right angle. So now I can come back and cut this piece in half and this piece in half to get 4 if I wanted. Okay, so I'm not going to give you any new homework. There is a section in the packet on doing geometric constructions if you want to do it. I'm not going to force you to. What I showed you here, I mean, it's kind of neat to be able to do it, but with computers and computer-aided drafting, it's not something that's vital anymore. Copying an angle, you just tell the computer to copy the angle it's going to do. But I show you this just in the 10 minutes we took here, because there are times when you're going to be sitting there messing around with a piece of paper, trying to sketch things out and you want to get it relatively close, probably not going to have a compass with you, but you can just take a piece of paper, and I've done it before. You mark a distance out on the corner of the piece of paper, use that corner as a pivot, just hold it with your finger and strike it, or you have a piece of string or whatever you have that you can hold one end and use the pen or pencil to strike an arc. There's a lot of things you can do with that. So no homework, but there is quiz 49 and 50 out there for you to work on. Tomorrow is our Unit 3 test already. Tomorrow's class will be dedicated to Unit 3 test. I will actually get that put out there. Hey, actually, I already put it out there this morning, so it's out there right now for us. Do you have any questions? Okay, well, hey, you guys want hard copies of the quiz and the test? Get those out to you.